Go. There she is. All right, so first thing we are going to do, and I might have you guys read things to me, is we're going to be going through shoulder flexion. So I want you to stand facing the windows, please. Cool. I'm going to align my axis with what? Read the chart.
Center of the humeral head.
Center of the humeral head, yay! And then both of my arms go where?
Parallel to the humerus.
Parallel to the humerus, awesome. And then my stationary arm is going to stay parallel to her to her midline of her body, and my moving arm is going to follow her lateral epicondyle as she comes into shoulder flexion. Go ahead and raise your arm up all the way over your head. Squeaky. We went from 0 to 155 degrees. Come back down. To start shoulder extension, we do the same thing. We're in the same position. We are coming along the midline of the body with our stationary arm. The moving arm is going to follow the humerus as she reaches back behind her. Go ahead. And ideally, I would be here, but I don't want my butt in the video. So, hence, I mean, it's fine, but, you know. Okay, and then relax. That is 38 degrees, okay? Shoulder flexion, shoulder extension. Yes. All right. Shoulder abduction. Now, what the heck? Okay. Yes. You can either do this anteriorly or posteriorly. I'm going to have you face this way. I'm going to line our I'm going to line our axis up with her acromion, okay? So I can find her acromion process, the anterior acromion here, and I'm going to line that up. The stationary arm stays parallel along the side of her body. The moving arm is going to follow her humerus as she comes up into abduction. Go ahead and come up like you're doing a snow angel. Beautiful. 0 to 162 and back down. Cool. Shoulder internal rotation and external rotation. She's going to bring her elbow to 90 degrees. I'm going to bring the axis of the goniometer right underneath her elbow. She's at 0 right now. The goniometer is perpendicular to her body. Okay? When I ask her to move into external rotation, my stationary arm stays straight front and back. The moving arm is going to follow her ulnar wrist. So go ahead and come external rotation. Beautiful. Stay there. And then back to neutral, that was 75. And then 2 ways that you can do internal rotation. One is to line it up the same exact way as external, have her come into her stomach. Go ahead. It's very squeaky, it's very squeaky. And that was 55 degrees. The other way to test internal rotation, if you want to see if they have a little bit more functional motion, is you can ask them to put their hand on their hip or to put their hand behind their back. All right, if I do this, I'm not using my goniometer. What I'll do is I will actually find the spinal level that she's at, and I will say, oh, she's at L1. Okay, she's just below her thoracic ribs, and so she's in her lumbar vertebrae. Her thumb is at L1. That's how I would document that. That gives me a lot more information than 55 degrees of internal rotation. Does that make sense? Mm-hmm. Right. Okay, cool. You can relax. Cool. Elbow flexion and extension. Go ahead and turn sideways again. This one, we're going to start with the goniometer completely open. Okay, my stationary arm is going to be aligned with her humerus. The axis is right at the lateral epicondyle. I'm going to have her come into neutral position with her forearm, and she's going to go as straight as she can with that elbow. Straight, straight, straight. Oh, no, straight. Go straighter. That's it. 0, so that's our extension. So we're going to write 0 for extension / when she comes into flexion, go ahead and come all the way into elbow flexion. Meow. To 142, and then relax. Cool? Cool. So extension, 0. If she hyperextended, how would I document that? If she went 10 degrees hyperextended? Negative 10. And then I would write a little asterisk, and in my note, I would say negative denotes hyperextension. Okie dokie. For supination and pronation, you're gonna stand facing the camera again. Cool. Elbow by your side. Sorry, I'm handshake position. I wasn't clear. You can use this big boy, but I like the smaller boy, the little wristy guy for this because it has a flat side and so it's easy to see where I'm going with pronation, supination. So if I'm going supination first, my axis comes proximal to her wrist crease and proximal to this ulnar styloid. So I have to come onto her forearm because I'm measuring forearm motion, okay? If somebody wears a watch, I actually have them keep the watch on and I'll go proximal to that watch because again, it's gonna keep me on their forearm, okay? So I'm gonna line up my axis just like level with her ulnar styloid, proximal. The stationary arm stays parallel to her humerus. The moving arm is gonna follow her radius and ulna as she comes into supination. Go ahead, turn palm up. 0 to 80, come back neutral. That was supination. Now I'm gonna do the same thing on the lateral side of the wrist, same positioning, but just on the dorsal side. Now come palm down, 0 to 80. Excellent. All right. Most of the time I do my wrist range of motion seated, but we're gonna do it standing for the purposes of this exam today. Wrist flexion, aha. Cool. So you're gonna come up like you're gonna arm wrestle me. Yeah. Good. I'm gonna keep and the way that I'm measuring the upper extremity and the wrist specifically is the way the American Society of Hand Therapists and Hand Surgeons does it. I am a CHT. This is the way that is used most in research. It doesn't mean that the other ways that you might learn are bad or wrong. You just want to keep it consistent with whatever you want to do, okay? So for wrist flexion, I start on the dorsal side of the wrist, so on the back of the wrist. My axis comes to the capitate. My moving arm aligns with her third metacarpal. My stationary arm aligns with the midline of her forearm. I ask her then to just make a flexed wrist, let your wrist bend down. This guy follows, boom. And I want you to look here. I want you to look right here. There is a little hole here in between her wrist and the goniometer. That's normal and okay. We don't have many right angles in our body, and so we have to kind of approximate, okay? That went from 0 to 80, good. Come back into a neutral position. So that was wrist flexion. I was on the back side of her wrist. Now I'm gonna do wrist extension and I'm gonna come on the palmar side of her wrist. All right, still capitate alignment, still moving arm aligned with her third metacarpal, stationary arm aligned with her midline of her forearm. This is a little tricky because our hand, again, is not flat. We have our palm, so we're keeping it parallel at first, and then when she comes into extension, watch what happens. Go ahead and bring back. I can align that beautifully, okay? So we went from 0 to 45 here. Awesome sauce. Wrist. Radial and ulnar. You're gonna look like you're voguing. Come like this. So normally when I do this with a client, for wrist flexion extension, I have them down on the table, they go meow. And then if I'm having them do radial and ulnar deviation, I have them rest their hand down. But for the purposes of this, I want you to be able to see it. So she's in supination here. My axis aligns with the capitate. My moving arm aligns with her third metacarpal. My stationary aligns with her medial the midline of her forearm. And then she's gonna go toward the thumb side. She went from 0 to 20 degrees toward radial deviation, come back to neutral, over toward the pinky side. From 0 to 40 degrees, come back to neutral. Is that normal? 20 radial deviation, 40 ulnar deviation? Yes, you're right, it is normal, and the reason why is because we have a longer radius than we do in ulna. When we come into ulnar deviation, we have a lot more space to go. When we come into radial deviation, we find bone on bone. So that is normal. The first time you measure that for somebody, they're gonna be like, I'm not equal. reinforce that that's okay. That's a normal thing. All right. Fingies. Switching Goni. Now, you can do fingers with this goniometer. I like the metal short little baby boy just because this short arm allows for our little phalanges to be measured a little bit more appropriately. All right, so I'm not going to measure every single finger. I'm going to show you what happens on the, actually come this way, yes. So I'm going to measure her small finger at the metacarpal joint, MCP joint, at the PIP joint, and at the DIP joint, okay? I'm going to measure extension first. I want you to extend your fingers as much as you possibly can, okay? This is where my stationary arm and my moving arm are going to look like they're flipped, and here's why. If I align here, sometimes this doesn't line up nicely. I upside down it and it's fine, okay? But basically our axis goes right over the joint. So at the volar MP joint, I align both arms, one with the proximal metacarpal and one with the proximal phalanx, and she hyperextends here 25 degrees. So negative 25 at her MP, yeah? At her PIP, she's at 0. At her DIP, she's at 0. Awesome. So I just measured her extension for that entire small finger. All right, that's all on the palm side. Now to measure her flexion, first thing I'm gonna have her do is we're gonna measure the MP, come into a duck position. As much duck as you can. Good. My stationary arm aligns with her 5th metacarpal. My moving arm aligns with her proximal phalanx. She flexes at that MP to 70 degrees. Yeah. Now she comes into a claw. I'm gonna measure, ooh, cricky cracky. I'm gonna measure the PIP. I already know her extension, so I can literally just bring this bad boy onto here. Stationary arm along the proximal phalanx, moving arm along the middle phalanx, and she flexes to 105 degrees. This angle at our PIP tends to go past 90. So when we're measuring this, always take a look at what that angle looks like and make sure that you're not going, oh, it looks like it's 75. No, it's not. It's usually going to be a bigger number than 90. And then I can just shift this right over to here with the distal phalanx and the middle phalanx, and we're in flexion here. We're in flexion of 75. Yes? Yes. Viewer. See, we just did all that. We just did all that. All right. Yes. Thumb MP flexion. Let's come a little closer. Let's bring your hand down here. Yeah. Turn palms up. Good. So for her MP here, this metacarpal phalangeal joint, I am going to align dorsally to get her full extension. Go ahead and come into full extension. She doesn't quite come into full extension, so that's why I'm doing this dorsally. So she starts at 20 degrees. All right, so her MP extension is 20 / when she comes into flexion, I just follow that right across here. So she went 20 to 60 degrees, so her total range of motion there is 40. That makes sense? She kind of started at a bend, and then she went even more to a bend. She can't fully extend that particular joint. Everybody's thumbs are a little bit different, and so you just have to kind of roll with that.
Yeah, Bryn, you're going pretty far. This is all I got.
For
real? Yeah. I feel like that one's wider.
For thumb opposition, friends, for thumb opposition and retroposition, they're a little funky with the Goni. Opposition, we're just doing functional. I say, can you touch your index finger? How about middle? How about ring? How about small? Now slide that thumb down as far as you can into your palm. She can come right to like just above her distal palmar crease. So I would say that her thumb can oppose to her 5th metacarpal head. Okay, that gives me again an idea of functionally where she can reach with that actual thumb. Okay, hand flat on the table here for a hot sec. Yep. Thumb retro position is the ability to lift your thumb up off of the table. So everybody put your hand flat on the table. Exactly. You want your chicken wing to stay down on the table, but you're gonna lift the rest of your thumb up. And then what we're gonna do is bring our goniometer perpendicular to the floor. Go ahead and lift up. And you're gonna align it with the top of the finger, not the nail. So she's at 4.5 centimeters. We measure that in centimeters. In general, we're gonna use the metric system when we're going through Goni and measurement stuff. Cool. Stay here. For palmar abduction, for the thumb, 2 more things, friendos. 2 more things. Okay. We can do it. For palmar abduction is shut up, a duck. Everybody do it. Yeah. So when we're measuring palmar abduction, we need somebody to get into handshake position. I'm going to bring my little Goni right here. My stationary arm is going to align with her second metacarpal. My axis comes down right to the base of her CMC joint, the carpal metacarpal joint of her thumb. So it's gonna look like this to start. Stays parallel to her first metacarpal for the moving arm, and then she's gonna come into grab a jar of peanut butter. Everybody understands grab a jar of peanut butter. We went from 0 to 35. Good. Now we're gonna go radial abduction and we're gonna go palm down. The alignment is the same. Second metacarpal for the stationary arm. The moving arm is gonna align with the first metacarpal. Squeeze in as much as you can to start. Good. So she's starting at a little bit of, because she can't come parallel with her 2 bones, and that's okay. So I'm just gonna say that she's starting her radial abduction at 10 degrees, and then go ahead and come out to the side. Sweep your thumb out as wide as you can. And then she comes to 35. So 10 to 35, so that's 25 degrees total motion. Awesome.